Hi friends, in this video let us learn about common drain amplifier. So the other name for common drain amplifier is source follower. So it is also known as source follower. Right, the circuit diagram for common drain amplifier is given here. So it is VDD. So then we have two bias resistors R1 and here we have R2. Then MOS is like this. Here this is source resistor RS. Here we have I. So since it is RS is there, we put it is RI. Then RSI, we use it RSI signal. So it is ESI or ES simply. Right. So the output is taken across what you call in drain. So this is drain terminal, it is gate terminal, it is source terminal. Right. So in AC equivalent, we know DC should be 0. That is VD should be 0. So VDD is grounded. So it is common between what you call input and output. So that's why it is called common drain. Right. So this is the reason for calling it as common drain amplifier. Right. Okay. Now we draw small signal equivalent. Here for MOSFET only we have to draw, so other things will remain as it is. So it is VSI. Here we have RSI, right? And bias resistors will become like this: R1 parallel R2. Then we have gate up to this, no issue, right? Then we draw the small signal equivalent of MOSFET. So it will be GM. Okay, GM VGS. GM-VGS. Then if I include channel length modulation, RO will come into picture. Here, this is grounded. Here I take VO, right? So this is source. We know the voltage is taken across, output voltage is taken across source, so we have taken VO here, right? With the source, we have one resistor, that is RS, and here we connected ground, right? So R1 parallel R2 is connected to ground only. So we have connected, all are connected to ground. Okay, this is drain terminal, this is source terminal, right? So if I draw in simpler fashion, what I do, I redraw the circuit. So this is VSI, RSI, R1 parallel R2. Then you see here gate will come, right? So this R1 R2. Then here VGS plus minus. What I do is I shift to the direction. It is going bottom side. No, I redraw it and making it come at top side. So here you see VGS, it is VGS plus minus. So if I put it, it will come up, so minus will come. So that's why it will become VGS minus here, right? Then VGS is the top direction. So this is GM. Sorry, the direction should be changed. It will be like this. GM VGS, and with that one source resistor that should be grounded. And then we have on a regular resistor RO due to the channel length modulation. Then in the bottom side we have taken output. Now it comes to the bottom side. All the bottom side will come to top side. Okay, fine. So now we will find all the parameters that is required to be obtained. So first we find VO, output voltage. See, this is voltage across this parallel resistance RO parallel RS. What is the voltage across RO parallel RS? There is a current flowing through, that is GM-VGS. This is I, R is RO parallel RS. So this is the output voltage. Okay, now we have to find the VGS. VGS I need to find. So I take this loop. For that I write KVL. So here plus VGS, here VO. VO is plus minus. So plus VO is equal to, here let me assume this voltage across this one is VN. So it is plus minus means minus VN. So equal to 0. KVL in this slope. I applied KVL. So from this I understand VO is equal to Vn is equal to VGS plus VO. This is equation number 1, right? So, okay, let us simplify further. VO, we know this one. So, Vn is equal to VGS plus, instead of VO, we substitute GM into RO parallel RS. So if I simplify, VGS is equal to Vn divided by 1 plus GM RO parallel RS. So VGS is equal to 1 by GM, I take outside, 1 by GM divided by 1 by GM plus RS parallel RO into V. So let us take this equation number 2, and this is equation number 1. Okay, right. So next what we are going to find, we find Vn. Vn is given by, what is Vn? Vn is the voltage across R1 parallel R2. Let me assume R1 parallel R2 is Ri. So Vn is nothing but VSI, apply voltage divided by VSI into Ri divided by Ri plus RISI. So what is the thing? Vn is equal to VSI into Ri divided by Ri plus RSI. This is 3, right? So this Vn you substitute here and substitute this VGS in equation number 1. That means substitute 2 and 3 in 1. So substitute 2 and 3 in 1. What I get is VO by VI. I will get that is equal to AV. That is GM into RS parallel RO divided by 1 plus GM RS parallel RO into Ri divided by Ri plus RSI. Simply AV is equal to RS parallel RO. I take GM outside, so GM will be cancelled. So it is 1 by GM plus RS parallel RO into Ri by Ri plus RSI, right? Okay. So you see from this we can say AV is less than 1, right? It is RS plus RO plus some value. So surely AV must be less than 1. If RSI is 0, it will become 1, right? Okay. So now we find Rin. So here the input is, it is common drain. So drain is grounded. Input is given between drain and ground. So sorry, gate and ground. So sorry, gate and drain. So drain is ground. So you know in gate what is I? Ig is 0. Ig 0 means what is Rin? Rin is equal to Vin. Input voltage by input current. Input current is 0. So ideally it is infinity. So for common drain amplifier, the input impedance is infinity. Right now we will find RO. What is the output impedance? You see from the diagram itself we can say directly what is RO. Right. So from diagram we understand. You see VGS is the voltage across this current terminal. Right. This is VGS. This is voltage across this current source. So what is the resistance if you neglect this RO? What is R, capital RO? V by R. V is nothing but VGS. I is GM VGS. So what happens? VGS will be cancelled. So what is RO? RO is nothing but 1 by G. So for common drain, so the RO is 1 by GM. Then if you have this one, you put parallel RO, parallel RS. Right? What is the reason? You see, we can use this one. So GM VGS. So here, what is the resistance? The resistance across this current source is GM VGS. That's what we have found. Sorry, 1 by GM. Right? Parallel RS, parallel RO. So RO is nothing but 1 by GM, parallel RS, parallel RO. So from the circuit, we can directly see. So from this, what we conclude is for common drain amplifier, AV is equal to GM, right? So we studied all the things. AV is equal to GM RS parallel RO divided by 1 plus GM RS parallel RO into Ri divided by Ri plus RSI, where Ri is nothing but R1 parallel R2. Rin is infinity. RO is equal to 1 by GM parallel RO, sorry, parallel small RO, not capital RO, plus RS. That's all about the session. Thank you.